Social scientists have found that it's very important when people are interacting with each other that we synchronize our rhythmic movements. So our gesturing and our speaking and everything is a lot like a dance. And I'm trying to get a robot to be able to synchronize to those rhythms. This is a robot named Keep-On, designed by my partner in Japan, Hideki Kojima. The design of the robot is really meant to be as simple as possible. It should be able to express some simple emotions about the things it sees through bouncing or sort of rocking, curious rocking behavior.
We try to choose names that somewhat sound good, you know, start with a G. Yeah, this is Gary the Guide Bot.
Excuse me.
It's interesting that in all the installations that we've done, the people, the staff that use it, always name the robot even before it shows up. There's usually a naming contest. So they really embrace the robot as part of the staff, not just another tool.
This robot's Professor Chaos. It's a 120-pound combat robot. Has a 22-pound blade that spins at 3,000 RPM with a single tooth. This robot is competed in what's called Robo Games. It's essentially the Olympics of robotics. By the end of the competition, we got first place undefeated, actually beating last year's champion twice in a row.
We brought academics in, we brought investors in, we brought robotic people in, and we brought people from big companies who are looking to robotize their product. And so we just took all these people together and said, everybody's welcome, let's go to one place in one location, just shake it up and see what happens.
So this is a teleoperation robot. I'm feeling all the forces that are felt at the end of this tip back on the wand here. It would be impossible to do remote surgery without haptics and without force feedback.
Imagine a gravity vector or line pointing from any point in space directly towards the center of Earth. So with respect to that line, accelerometers can detect position.
Primary weapon is the front disc, and it spins at 3,000 RPM, and it hits the other robots, can launch them 4 feet in the air. And what that will do is it can flip them over so they can't move, puncture their armor, so we destroy internals. In one match we went through 1/4-inch titanium. Overall, just high trauma, and the other robots knock things loose and break them.
Keep-On was designed originally for autism therapy and social development research. So interaction with kids. The therapist can see what the robot sees through the cameras in its eyes and hear through the microphone in the robot's nose, and basically do a Wizard of Oz kind of mediated interaction with the kids in the playroom.
Well, it's actually more than a remote control toy because it's also programmable. It's really easy to program. It's like a stop-motion keyframe animation package. So kids, 8 and up, can get the robot, position it in position 1, move it to position 2, set a time between those positions, and then the robot will act that out.
In some ways, the human body is just a machine. It's just an organic machine as opposed to an inorganic machine. So again, we have sensors. We sense the world around it with our 5 sensors. We take that information, we use it to make some sort of decision, and then we act on that in the real world. Certainly, robots don't have emotions or anything like that yet.